Hi, Professor. This is Anna from class for the capstone for 95. Anyways, I was just looking at like our warm-up problem from this past class period, and I was sort of using that as an extension for one of my daily works, and so I just wanted to spend a little bit of time going over the extension of that problem, so like kind of making it bigger, and I'm actually going to spend just a couple minutes explaining why it really doesn't work if you want to keep the shape of the cross like symmetric, and I just thought that I would explain it because it would be a little bit easier than writing the whole thing down, and I hope I do an okay job of explaining it, but here we go. Okay, so this is sort of an example of what we started off with in the warm-up. So we have to find two terms that when they multiply together equal negative 990, and then when you add them together they equal 3. So kind of like a different way to visualize what we're doing when we are factoring. So a solution to this problem would be negative 30 and 33. So that works. So what I was doing, sort of as an extension for this problem, was I was looking at what we can do when we have a shape like this. So I just kind of consider this like taking this one step further, because it has the same type of shape, but we're just making it a little bit bigger, and it's still symmetrical and stuff. So this problem worked out really nice when I started it, because I thought to myself, well, 3 multiplies by 11 to get 33, so that's good, and 3 multiplies by negative 10 to get negative 30. Great, so far so good. So this was where I kind of ran into some issues. I needed two numbers here that, well, first of all, if we're following the pattern, we're going to get 3 plus 11 is going to give us 14. And negative 10 plus 3 gives us negative 7. And this is where I ran into that issue, because negative 7 times 14 does not give us 3. So I looked at a couple other examples that worked really nicely up here and even to this third step, but when coming down to the fourth step, I would always get like an issue. And so I tried to look at this problem a bit more generically, so I'll kind of write this out here for you. Suppose we start with any number right here. We'll just call that number n, and it's divisible by two numbers, x and y. So if we think, and by the way, I just want to say, I think this was true for the warm-up, we're just dealing with the integers. So negative whole numbers and positive whole numbers, omitting 0, because that would just, I think, kind of make this a little bit weird. We would get 0 here, which means that this number would be 0, and there we have like a mess on our hands. So we, by just this rule, we know that x divides n and y divides n. This square right here is going to be the sum of x and y, so it's going to look something like this. And this right here, this term is going to be some number, I'll just call it m, and that's going to be dividing y, and x plus y is going to be dividing y. Coming over here, we'll have a number, I haven't used p yet, so we'll use p, and that's going to be dividing x, and x plus y is also going to be dividing x. So far I don't really see much of an issue in this. This could be possible. When we come to the next step, we'll see where that contradiction is. And I also want to say something about absolute value too. So because x divides n, we know that the absolute value of x has to be less than or equal to n, and same with the absolute value of y has to be less than or equal to n, and we're going to be dealing with the absolute values again when we come down here. So following our pattern, we know that p plus x plus y goes here, and then this is going to be m plus x plus y. And this is where we sort of have an issue. So we know just from like looking at this that what we've written is p plus x plus y times m plus x plus y is going to give us x plus y. So that being said, we know that the absolute value of this term must be less than or equal to x plus y, and the absolute value of this term must be less than or equal to x plus y. But that's an issue because we have x plus y right in here and an x plus y right in here, and we're adding a term to it, a whole number. Again, we're not dealing with fractions. So if we're adding a whole number to this sum, we're going to be getting an absolute value that's going to be greater than x plus y. And according to this, that can't be. So just kind of going off of the extension of the problem from the warm-up, I think we just proved right here that we can't really go much further. I think that if we were to do something kind of to the angle like this, it might work out, but if we want to just bring this pattern straight down, I don't think it's going to work because of this right here. So, all right, well, my mom's calling for dinner, so that's all for now.